Normal distribution part 3, we're going to talk about z-scores. Let's look at this very simple example. We have a set of measurements of 105.0 centimeters is the mean, and standard deviation is 1.5 centimeters. We'll assume this is a normal distribution. We wouldn't be doing z-scores if it weren't. Let's make our chart. 105 in the middle, 105.0. 106.5, 108.0, 109.5, just count off by 1.5. Subtract 1.5, 103.5, 102.0, 100.5, and these are centimeters. You can put labels on them. Now we can use this to figure out what a z-score is. Z-score is just a fancy name for number of standard deviations from the mean. So right in the middle, we're at the mean, z equals 0. We go up one standard deviation, z equals 1, z equals 2, z equals 3. Now when we come below, that's one standard deviation below, z equals -1, z equals -2, z equals -3. So for some simple problems, you can just eyeball it. 106.5, guess what? That's z equals 1. 105.0, you can do A, C, B, D if you want. 105.0, that's z equals 0. 102.0, guess what, we're right here. Z equals -2. 105.75, well, you may see you're halfway between here and here, halfway between 0 and 1. Z equals 0.5, but it's a very complicated, this is what's called interpolation. You can actually use this formula, z equals x minus s over x bar. Let's test that out. X is the score, 105.75, minus, oh, sorry about that, I got the formula wrong. My mistake. So x minus x bar, 105.0, divided by standard deviation, 1.5. That's equal 0.75 over 1.5. And you could do any of these calculations in a calculator. Do that on a calculator. It's 0.5. There's no units on that. It's just a dimensionless number. So if this were, for instance, x equals 105.9823, well, of course, we would need that formula, which I surprisingly got wrong. So, okay, I think that takes care of the homework. So.